Hello, this is Mrs. Ross, and this is Lesson 103, Practice Set and Starred Problems. It says that we'll need a protractor. We're going to see about that here in just a minute. Okay, so we're simplifying problems today. I highly suggest that you write every single step down. These are the kind of problems that when people do them in their heads, they forget a step. And I know that it can be tedious, and I know that you think, well, I can do this in my head. But if you can't do it in your head 100% correctly 100% of the time, I highly suggest you write every step down. So we're going to take this 2 at a time. So -5 times -4 is positive 20. And then I'm going to bring my -3 down. Positive 20 times -3 gives me -60. And then I'm going to bring my -2 down. -60 times -20 is a positive 1, or -2 is positive 120. Bring my -1 down, and so this is -120. You can kind of see with all the different signs that it might get a little bit confusing if you don't do it step by step. So let's go over here. Okay, and we'll do the first two. Positive 5 times -4 is a -20. And we bring our positive 3 down. -20 times a positive 3 is a -60. Bring our -2 down. -60 times -20 is or -2 is a positive 120. And this is positive 120. Keep in mind that a negative times a negative is equal to a positive times a negative is equal to a negative. Okay, so we have -2 cubed, and if I take this out, it's -2 times -2 times -2. Okay, so then I have -2 times -2 is positive 4, times -2 is -8. Okay. Here I have -3 to the 4th, which means I have -3 times -3 times -3 times -3, 4 times. So I take the first two, -3 times -3 is a positive 9, times -3 is -27, times -3 is positive 81. Okay. So here we have -9 squared, which is -9 times -9, which is positive 81. And let me change colors here. So here I have -1 to the 5th, 4 and 5. Okay, so this is going to be positive 1. This is going to be -1. This is going to be positive 1. And the final answer is -1. I think what they're trying to show you, and I think if you go through the lesson, is that when you have a negative number taken to an odd exponent, you're going to get a negative answer. When you have a negative number taken to a positive exponent, you're going to get a positive answer. Instead of remembering that rule, I just multiply it out. Or you can remember the rule, that's fine. Okay, these are fun. We are simplifying these, and this is what we're going to do. 6 times A, B, 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 and C. So I have 2 A's, 3 B's, and a C over 3AB. So let me go ahead and see what I can reduce. I know that 3 goes into 6 2 times. I have A and B and B. I can't change anything else, so let's see what I'm left with. On the top, I have 2, I have A, I have B squared C, and I don't have anything on the bottom. So that is my answer. I'm just simplifying. Okay. I'm going to do the same thing here. I have 8x, 1, 2, 3, 1, 2, 6, x, y. Okay, so 2 goes into 6 3 times. 2 goes into 8 4 times. I have an x and an x that can go away, and that's all for x. I have a y that can go away, and that's all for y. So let's see what we have on the top. I have 4, and let me look along here. I have 2 y's, and I have 2 z's. And on the bottom, I have 3 and 1 x here. So this is my answer. Okay. All right, so let's write this one out. What I'm doing is I'm expanding them first so that we can see everything. M, N, N. Okay, so I'm going to divide these by 5, so I get 3 on the top and 5 on the bottom. And then I have M, and I can take an M away. I have an N, I have another N, and that's all I can take away. It has to be in the top and in the bottom to take it away. So I have 3, let's see, P over 5 M. All right, state whether the monomial is a perfect square. If it is a perfect square, find the square root of the monomial. So a perfect square is like 4, 9, 16, 25, that's 5, 36, 49, because this is 2 squared, this is 3 squared, this is 4 squared, 5 squared, 6 squared, 7 squared. Okay. Also, for the monomial to be a perfect square, all of the exponents have to be even. Okay? So it has to be one of these numbers, and all of the exponents have to be even. So here, this is not a perfect square because 12 is not a perfect square. So not a perfect square. Here, 49 is a perfect square, and these are all even. So this is what I'm going to do. I take the square root of 49, and then when I take the square root of a squared b6 c4, what I'm doing is I'm dividing the exponent by 2. So the square root of 49 is 7, and a2 divided by 2, b6 divided by 2, c4 divided by 2. So I have 7, a2 divided by 2 is 1, 6 divided by 2 is 3, and 4 divided by 2 is 2, and that is my answer. Okay, since this has an invisible 1 in the front, and 1 squared is 1, we can take the square root of this. So the square root of x to the 6 y squared is going to be x 6 over 2 y 2 over 2, which is x to the 3 y. Okay, and let me change colors here. Here 16 is a perfect square, so I have square root of 16, which is 4, but 3 is not even, so we cannot a perfect square. All right, and then these are the starred problems. So instead of getting into the starred problems, I'm going to go ahead and stop this now so you have the practice set all in one video, and then I'll start the lesson 103 starred problems in a separate video.